So what we have here is the product of these two factors, and we get this quadratic term x squared plus 25. So to find the third factor, which is the real factor here, or the real zero, is we need to divide the original polynomial by the quadratic term. And we could do that two ways. We can use synthetic division, or we can use long division. And the reason those things were already up were because I made a mistake, and I was trying to figure out what mistake I made. So I've figured it out, which took me a long time to figure it out. It wasn't that hard to figure it out. So anyway, the question is here, what do I need to multiply by x squared by to get 2x cubed? The answer is 2x. So 2x times x squared is 2x cubed. 2x times 25 is 50x. That was the problem. I put down 50x squared because I forgot that there's no linear term in there. Okay, then you subtract these. So this goes to 0, that goes to 0. You're left with 3x squared plus 75. So now the question is, what do I multiply x squared by to get 3x squared? Well, the answer is 3. 3 times x squared is 3x squared. 3 times 25 is 75. Subtract those, I get 0. So my additional factor here is 2x plus 3. So the 0, the real 0 is, you set this equal to 0. So you set the factor equal to 0. And if you solve for that, you'll get x is negative 3/2. Now, I can do the same thing over here. Actually, this is to confirm that this is the 0. So if I put 3/2, if I take the original polynomial and divide by x, so the factor is actually x plus 3/2 equals 0. What'll happen is you bring this down. 2 times negative 3/2 is negative 3. 3 plus negative 3 is 0. Negative 3/2 times 0 is 0. 50 plus 0 is 50. 50 times negative 3/2 is negative 75. So if you did that, you get, what you would get is 2x squared plus 50, which is the same as 2 times x squared plus 25. So anyway, that was kind of to check. What I did is I plotted this function, found the 0 was here, and I just wanted to see why I couldn't seem to figure it out. It's one of those cases, just had a mental problem. Okay, so the same kind of deal here. So this says that one of the zeros is x is equal to 3i. So the corresponding factor associated with x equals 3i is x minus 3i is the factor. So the complex conjugate would be x plus 3i. So that's the other 0. The other complex 0 is the complex conjugate. So if we now multiply these things together, we'll get x squared. The inner and outer will cancel out. You'll have negative 3 times positive 3, which is negative 9. I times I, which is I squared, which is negative 1. So we'll get x squared plus 9. So that is the quadratic term that has no real zeros, but it does have 2 imaginary zeros. So again, what we can do to find that last factor that we're looking for, the last 0, is we're going to take the original function. We're going to divide by this quadratic term. Okay, what do I need to multiply x squared by to get x cubed? X. X times x squared equals x cubed. X times 9 is 9x. I subtract both of those terms from the original polynomial. So this goes to 0, this goes to 0. I'm left with x squared plus 9. What do I need to multiply x squared by to get x squared? The answer is 1. 1 times x squared equals x squared. 1 times 9 is 9. Subtract that, you get a remainder of 0. So the original function can be shown as x plus 1 times x minus 3i times x plus 3i. So the third 0 is x equals negative 1. You're saying, well, it's positive 1 over here, but no, that's, we set the factor equal to 0. Solve for that. That gives us, setting the factor equal to 0 gives us the 0. So it has one real 0 again, two complex zeros. Okay. So let's look at this one. So it's missing the x squared term. We're not given any information, so we're going to have to guess what they are. So what we're going to do is we're going to look at the use the rational zero test. So the factors of 6 are plus minus 6, plus minus 3, plus minus 2, plus minus 1, q, just plus minus 1. So if we look at p divided by q, it's basically all these numbers. Plus minus 1, plus minus 2, plus minus 3, plus minus 6. So these are the zeros, possible zeros. So what we can use synthetic division to do this the quickest way. Put the coefficients of the original polynomial in. Remember, there's a 0 for x squared. And typically you choose 1 first. See where we get. So we're going to choose 1. X equals 1. So we bring 1 down. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. 1 times 1 is 1. Add this together is 0. 1 times 0 is 0. We get 6. Okay, so what that says is, in this case, the function is h, not f. So we get h of 1 equals 6, which is pretty close to 0. So we might want to try 2 next. So let's try x equals 2. See what happens. 2, 1, 0, minus 1, 6. So we bring 1 down. 2 times 1 is 2. 0 plus 2 is 2. 2 times 2 is 4. Negative 1 plus 4 is 3. 2 times 3 is 6. 12. Okay, so it's going in the opposite direction. Make sure I did all that right. Bring that down. This multiplied by that. Add those together. Multiply that by that. That's good. Okay. So that means I should probably try negative 1. So negative 1, 1, 0, negative 1, 6. Bring that down. Negative 1 times 1 is negative 1. 0 plus negative 1 is negative 1. So then we have negative 1 times negative is 1. 0. 0 times negative 1 is 0. 6. Interesting. So it says that x equals, and so again, h of 2 is 12, and h of negative 1 is 6. Does that make sense? Something doesn't make sense. Because if you do x of 0, you get 6. So how the heck is that happening? Because if h of 1 is 6, h of negative 1 is 6, and h of 0 is 6. That's some strange. Strange behavior. So let me just double check my numbers here. 1 times 1, 0, 1, 0. Okay, makes sense. Negative 1. What does negative 1? Negative 1 times 1 is, yeah. Well, that seemed to work. Okay, let me just double check this one, see whether that. Okay. So that seems to be right. So I'm still puzzled. So I'm just going to think about this for a minute. So let's just plot these points. So here's negative 1, here's 0, here's 1, 2. So it says h of 0 is 6. It says h of negative of 1 is 6. H of negative 1 is 6. And this one's like that. So I don't know how that happens, because you think it goes like this, if it goes back up like that, it would have to go back down like that. So I guess that's possible. Okay, well, that's the only thing that can happen. So that just kind of blew my mind. So the other option now, because of that, and this is positive, so it has to go, the end behavior says it has to happen this way. So it looks like negative 2 might be a good choice. Let's see what happens there. Negative 2, 1, 0, negative 1, 6. Okay, so you bring 2 down. Bring 1 down. Negative 2 times 1 is negative 2. 0 plus negative 2 is negative 2. Negative 2 times negative 2 is positive 4. Negative 2 times 3 is negative 6. 0. There we go. Okay, so what that's saying is that x equals negative 2 is 0. Now this would indicate that there are no other real zeros, and you can figure that out because you can take what's left over and make the quadratic out of that. Okay, so that is what's left over. Now, if we wanted to factor that, we could use completing the square. So we take, move this 3 over there, and what we're trying to do is find out what values of x make that go to 0. So we take the coefficient in front of x, divide by 2, square it, which is negative 1 squared, which is 1. So we add 1 here, and we subtract 1 there. So that becomes x minus 1 quantity squared, and that's all equal to 0 up here, plus 2 equals 0. So we would get x minus 1 squared equals negative 2. Take the square root, we get x minus 1 equals plus minus the square root of negative 2. Square root of negative 2 is going to be square root of 2i, so it's going to be plus or minus the square root of 2 times I. Square root of negative 1 is I. And then we add 1 to both sides, so we get x is equal to 1 plus or minus the square root of 2i. So now we have all 3 zeros. 1 0 is, here are the zeros. So it's x equals negative 2, x equals 1 plus the square root of 2i, And the third one is x equals 1 minus the square root of 2i. So again, once you find one real zero, then you can either get the other two real zeros by factoring whatever you have left over. In this case, the thing we had left over was not didn't have any real roots. It had complex roots, but it still gave us 3 roots. And also this, when you try dividing using synthetic division and you end up with a remainder, you can use those to kind of think what's going to happen. So I had the points 2, 12, 1, 6, 0, 6 from the y-intercept, and -1, 6. And then I thought, oh, well, how can that actually happen? Well, the only way that could happen is if this thing looped down and looped back up again. And that led me to believe that this would not loop down far enough to go through 0. So I said, oh, there's probably only one 0, and it's got to be less than -2. It's got to be pretty close to it's got to be less than -1, because the way this thing was moving, it looked like it had to, this one here is 6 greater, so this one's probably 6 less. So that's something that kind of comes with experience. Okay, so that was it. Before we finish there, let's look at how you would just to prove that what we had here is the truth. So what I'm going to do is I'm going to take this. So the original equation can be factored. The factors look like this. Those are the zeros, but the factors are going to be x plus 2 times x, and then we'll have minus the zeros. So you have 1 plus the square root of 2i. So that's one factor. I need one more parenthesis here. It's not quite right. Okay, so there we go. And then the third factor is going to be 1 minus the square root of 2i. Okay, so that's the original function. What I wanted to talk about was, what do you do here? So the best thing to do actually is to leave them in the parentheses. So you have the whole second term. You treat this as one term, not as 3 terms. You'll see why in a second. Okay. Okay, so we're going to use FOIL. So first you'll get x times x, which is x squared. Then you'll have, so that's f. O is next, outer. So you get x times that, which is going to be negative the quantity 1 minus the square root of 2i. Then you have the inner, which is these two. So again, I'm going to switch the order. You'll have a negative sign from here. So what we're doing is taking x times that. So we get plus x times negative 1 plus the square root of 2i. Okay, so x times this. Here we take x times that. And then you have negative times the negative. So that'll be positive. So this times that's positive. And then you have 1 plus the square root of 2i times 1 minus the square root of 2i. So those are the 3 terms. Now, when you multiply this out, you'll have x times negative times 1. So for this part, you get negative 1 times x. So that's negative x. Now the second part, you have x times negative times this part. So that's going to be plus, because you're going to have this minus times that minus. and then you have x times the square root of 2i. So it's going to be x times the square root of 2i. This times that, sine times that, times the whole thing. Okay, now we go to the second one. You have x times negative 1. So that's negative x again. Then, where are we in this thing? Okay, then we have the last part. So you have x times, no, this one here, you have x times negative times positive square root of 2i. So this was ended up being positive x square root of 2i. This becomes negative x square root of 2i from this times that times that. And then the last part, you've got 1 times 1, which is 1. You've got plus square root of 2i times 1 and minus square root of 2i times. So the inner part of that multiplication goes to 0. And then the last part is you have the square root of 2, and we got a negative sign here. So this is negative because positive times negative is negative. Square root of 2 times square root of 2, and then I times I squared. Okay, you see those cancel out. This is plus x squared root of 2i, this is minus x squared root of 2i. These two combine into negative 2x. And then finally we have plus 1, this is 0, drop that. You end up with negative 2, square root of 2 times square root of 2 is 2, times I squared, which is negative 1. So what we end up with is x squared minus 2x plus 2, which I think is what we had, right? Trying to remember if that's what we had here. No, actually we didn't. That's not right. This is actually 3. Okay, so this becomes 2. 2 plus 1 is 3. Okay, that makes sense. So that matches up x squared minus 2x plus 3. So when we were down here, you know, that was what we had left over. When we correctly guessed the single real 0, we ended up with this as the quadratic expression, which we ultimately factored or solved for using completing the square. So anyway, I just wanted to show you how you would go backwards from the original, the factored result, and how you deal with multiplying two terms together, two factors together, where one of the second part of the factor is a complex number instead of just a real number.